Okay, so what I want to do in this lesson, I want to introduce the idea or the concept within chemistry of what's called the mole. So the mole. Now to try and understand like just what this means, I'm going to use this idea of if I was to say, okay, let's say if we talked about a dozen eggs. So a dozen eggs. That means, so let's say if we have 1 dozen, that's equal to 12 eggs. So it's pretty straightforward. So instead of saying 12 eggs, you could just use this word, a dozen, to represent that. Now, within chemistry, we have what's, instead of saying a dozen, we have what's called a mole. And we use this concept of a mole to count the number of atoms that we have. Now, as we know, atoms are extremely small, so they are. So therefore, we need this concept of what's called a mole. Now, just to put it into context, a dozen eggs means that you have 12 eggs. Now, if you had a mole, so a mole then, what that means, a mole of, let's say if you were to have a mole of eggs, that would mean that you would have, so this is the number that we use. So it's 6.02 multiplied by 10 to the power of 23. Okay, eggs. Now, this is a huge number of eggs. So if we think about 10 to the power of 23, so this is an unimaginably huge number. So to kind of just to put it into context for you, so another way to think about this, it's like saying 602, and then after this you would have 21 zeros. So imagine it would be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 602,000,000 eggs. So think about, that's a lot of eggs. Now, so it's an absolutely huge number. And the reason why this number is so big is because this is the number that we use to count atoms. And atoms are extremely small. So a way to think about it is when you have a mole of, for example, if we were to take carbon, that means that we have this number of atoms of carbon. So imagine you have 1 mole, so you have 1 mole of carbon, and what we use this letter as well to represent the mole. So it can be represented with a capital M like this. So this means 1 mole. So 1 mole of carbon will have 6.02 multiplied by 10 to the power of 23 atoms of carbon in it. So it's just like saying if we have a dozen eggs, we have 12 eggs in a dozen. Okay, there's 12 eggs in a dozen. Except instead of using a dozen, we use this word, the mole, and that represents 6.02 multiplied by 10 to the power of 23, which is this number here, number of atoms, let's say within a mole. So carbon. Okay, so that's what we mean by a mole. Now, there's a link then between like how does a chemist know? Let's say if I'm a chemist and I want to measure a mole of carbon, how can I go about doing that? Now, what I can do is I can use a balance. Okay, so just a normal balance. And we know that if you've ever weighed anything on a balance, it's measured its mass. It can be measured in grams, for example. So if you've ever baked something, generally you'll use a balance and you'll get the mass and it'll be in grams. Now, what we can do is we can work out, so obviously like this is a huge number and atoms are extremely small, but what we can do is there's a direct link between the mass that's represented on the periodic table and this idea of the mole. So if we think, so let's say if we have a look at carbon here. So if we look at carbon here, so we can see that carbon has a mass of 12. So this is its mass here. Now what I'm doing, I'm just going to round this up to 12. So the mass of carbon, so I'm just going to work on this over here. So the mass of carbon is 12. Now, there's a direct link between this. If I wanted to get a mole of carbon, so one mole of carbon will be equal to 12 grams. So let's say if I'm a chemist and I have carbon and I want to get a mole of carbon, what I can do is I can get a mass balance and I can weigh out 12 grams. And within that 12 grams, so if you have 12 grams of carbon, within that you have 1 mole of carbon. And then inside this 12 grams, so imagine this is your 12 grams mass that you've weighed out, so you have 12 grams here. Within that 12 grams, you're going to have 6.02 multiplied by 10 to the power of 23 atoms of carbon. So within that weight, so if you weigh out, let's say 12 grams of carbon, for example, you're going to have, within that, you're going to have 6.02 multiplied by 10 to the power of 23 atoms of carbon within that sample of carbon, within that mass of carbon that you weighed out. So similarly, if we look here on the periodic table, so if we have a look at other ones, let's say if I wanted a mole of oxygen, for example, if I wanted to get a mole of oxygen, okay, let's say if we were to look at, let's say silicon, okay, because obviously oxygen, it's hard to imagine weighing oxygen, it's a gas. So let's say if we take silicon, for example. So silicon, its mass is roughly, we round it to 29. So if I was to weigh out 29 grams of silicon, so I'll just use its chemical symbol, within that 29 grams of silicon, so let's say this is your mass that you've weighed out, within that 29 grams of silicon, you are going to have 6.02 multiplied by 10 to the power of 23 atoms of silicon. Within that, you're going to have 6.02 multiplied by 10 to the power of 23 atoms of silicon within 29 grams of silicon. And another way to think about it is if you have 29 grams of silicon, you're going to have this number of atoms, or you're going to have 1 mole of silicon. So that's the link. Okay, so that's how, if we want to find out, so it's very important that we're able to weigh out accurately, let's say the number of atoms of a particular product that we're interested in. So what we're saying is that there's a direct link. So whatever the mass is on the periodic table for that element, if you weigh out that mass in grams, so that a gram in grams, for example, that mass in grams, then within that weight that you've weighed out, you will have 1 mole of that element, or that particular atoms of that particular element. And this is really important in chemistry when it comes to chemical reactions. Okay. So that's what we mean by, so that's just, it's just a quick introduction to this idea of the mole. So again, when we think about the mole, it's very similar to the concept of a dozen eggs. In a dozen eggs you have 12 eggs. Okay, within a mole you have this huge number, 6.02 multiplied by 10 to the power 23, which is this, if you write it out, number. So it's like saying, so you could say, if you say a mole, this means this big number. So you could have a mole of anything. So a mole of eggs, for example, is a huge number of eggs. It's the same thing, same kind of concept as a dozen. For example, the word a dozen represents 12 eggs. The word mole represents this huge number here. And we use this to count the number of atoms that we have, because atoms are extremely small. And then what you can do is, if you want to get a mole of a particular atom, for example, if you need a mole of carbon, then what you do is you measure out in grams the mass of it, whatever it says on the periodic table. So in the case of carbon, it's 12. Its atomic mass is 12. So what you would say then is that within 12 grams of carbon, you're going to have a mole of atoms of carbon within that 12 grams. So that's what we mean by the concept of a mole. And again, it's a very important concept that you know and that you understand within chemistry. Now, just one other thing that I just want to kind of link to this as well. So if we think about this chemical reaction here, okay, so if we write something like this, okay, so we can have, so within this, so let's say, so what we're saying here, 2 moles of mercury, Hg, okay, so Hg, if we have a look here on the periodic table, so that's, it's mercury. So if we have 2 moles of mercury and we react that with 1 mole of oxygen, so, or 1 mole of oxygen, of the oxygen molecule, that will react and it will give us 2 moles of mercury oxide. So this number here that's in front of our chemical, so for example, you have the reactants on the left, you have your products on the right. This number that's in front, it represents moles. So what we're saying here is that if you have 2 moles of mercury, then you need 1 mole of 1 mole of oxygen, of 1 mole of oxygen molecules to react with each other to give you 2 moles of mercury oxide. So again, like, this is a huge number. So imagine if you have 2 moles of 2 moles is going to be this number doubled, okay, and 1 mole of oxygen. So again, like, what we mean here is we have 2 oxygens connected together, and you have 1 mole of this, okay, represented. So that's just another link as well when we're looking at when we are looking at chemical equations. For example, this number that's in front means moles, okay, so this means 2 moles of mercury, this means 1 mole of oxygen molecule, and then this means 2 moles of the product, which is mercury oxide. So that's the link between the mole and the mass that's on the periodic table. Okay, so hopefully that makes sense, and thank you for listening.